Hello, in this video we're going to learn how to make the Fibonacci Spiral. Looks like a snail or something, which is kind of structured on the golden ratio, which is like 1.618 something or other. Right, and we're going to do it in JavaScript using the P5 library. I'm also going to teach you, or try to do the ES6 standard, so ES 2015 standard, which means using the class syntax rather than making objects in the old-fashioned way. Nothing wrong with the old-fashioned way. So, how's this going to work? So every time I click or tap, if you're on a tap device, we can iterate. So that means create a new square object with a golden curve in it. So the idea is, just to refresh again, we want to have an object which is a square that has a golden curve through it. And if you think about it, the center of the curve is here. So if we were drawing a circle, it will go all the way around, and this will be the center. But we only want a quarter of it, so we're going to have to work out how to do that. And then what we want to do, to create the next square, we want to reduce the length, or the diameter of our square, by that golden ratio. So this length times 0.618. And then we want to draw that curve in exactly the same way relative to the new dimensions. So we're going to rotate the square by, that way, like 90 degrees, and then draw the curve again, and then so on and so forth. And once you've got objects, you can make as many of these little guys, like I've got over here, as you want. Right, let's get started, let's get going. So close him down. So I've got a new JavaScript file ready, which I will forget to attach to the HTML file in due course. Right, let's make an object. So what we're going to call it, first use the class keyword. So I want a new class of object. Oh, I just remembered, I've got this piece of paper here where you can, to demonstrate the golden ratio. The magic of it is that this is, I think it's like A5, and so like A4 paper, or foolscap paper. The idea is, with this ratio, once you fold it in half, you then got a new size of oh, I've got a phone number in there. I don't know whose phone number that is. You've got a new measurement of length, but the ratio to the shorter one stays exactly the same. And then you can keep going, and look, it's the same but scaled down. It's brilliant. And so you use this ratio to do that. Right. Okay. So we want a class. I'm going to call it a like a G box, a G box for golden box, and then we create space with the curly brackets for the, what's the time? Okay, for the body of our class object. So in here, we're going to have our member variables or attributes. Unlike the traditional object, and more like say classes in C++, we're going to create a constructor, which is like a little function that is called, as soon as you want to instantiate or make an object, this constructor function will be called to kind of like construct that object. So, and you construct it with its variables. So we want to tell it where its x position is, where its y position is, and maybe its width. And I think that's all we're going to need. That's all we're going to need. So we can say make a box now. Let's do that here. So in P5, you start with a setup function. Here we go. Setup. And so now we can say something like, I would like, better call him something, var Fibonacci. Let's call him Fibly. Fibly equals new. I use that new keyword to ask JavaScript to go and make a new object. So we want a new Gbox. There we go. And then you can tell it where you'd like it. So width divided by 2. That'll be half the width of that, the window that's loaded. Height divided by 2, and then the length of our box, 100 pixels. There we go. So that's how you would instantiate an object using ES6. Right, there we go. So we've got a Fibly. We haven't got a canvas and things like that yet, but let's just carry on making our box. So constructor function. This will now look familiar if you know the old traditional way in JavaScript to kind of make objects. So you now say this x, or this, I'm going to make use a vector, this pos equals create vector out of the x and y parameters that we've passed into our new object. There we go. So this position equals that, and this width, I've got it width equals the underscore w parameter that we've passed in. So actually, I think this should now work. It's a real object. So let's get something on screen. Let's see if we can make ourselves a canvas. And we're going to make it as big as the given window width, so we can use that variable, p5 variable, and window height. There we go. So our canvas will be as big as possible, and then background color. Now we're going to draw a golden triangle, so gold and blue go very well together. So we'll say 0, no red, no green, and like fairly low blue. Maximum would be 255. So we should have that working. Now I'm going to attach this JavaScript file before things go wrong. Right, before nothing happens rather. So that's the one that was working. You know what, let's just comment this out. Command / by the way, to comment out in either the HTML or your JavaScript file. I'm using the brackets editor. Something similar will work in other editors like Sublime or Atom. What am I doing? Oh yeah, I'm attaching this. I need you now. I need you back. And we're going to replace that name with our, what do I call it? Fibonacci tutorial 1. Right. There we go. Command save. Everything should now work. Okay, so what have we done? We've created our canvas, painted it, and we've tried to instantiate a new gbox. Let's write a function now in our class body to render the box to the screen. So we might call it render. Notice we don't have to put this dot render, just render, and we don't have to tell JavaScript it's a function. So it's very, very simple, very, very clean. Render, and all we want to do is translate to this box's position. So this dot position, and that's the x component of the vector, and this dot pos y, that's the y component. So that's now, because we've used the translate p5's translate function, we've set that as the center of our drawing. Okay, so then if we were to draw a rectangle from 0, 0, its center would be this position. That's what translate does. It kind of moves the center of your coordinate system to that position. Now we also want to use the center rect mode, American spelling. There we go. Because by default P5 will draw rectangles from their upper left corner, which makes sense because if you're doing 2D graphics, usually you're in the top left. Or are you looking at me this way? I don't know, like that, somewhere top left. But we want to draw our box from the center. Right, so we've translated to where our box is. So then we would like a rectangle, please. And the first two parameters are its x and y position, but we've already translated our coordinates to its x and y, so we don't want to move from there. So 0, 0. And then how long it is across its x and how long it is across its y. Now we're drawing a box, not a rectangle, so length and breadth will be the same. There we go, right, that's our render. So let's just see now. So where our program properly starts, is down here. Let's see if we can render Fibly. So we've instantiated Fibly. Let's see if he renders. I'm just going to give myself a little bit of space. Right, Fibly, could you please render? Right, command save. Moment of truth. Do we have something on screen? We do not. Something has gone wrong. So I'm going to bring up the already. I'm going to bring up the console with Command Alt J, and it has given me an error report. Let's see. Line 6. That's pretty early on. Unexpected token. An ordinary bracket of parentheses. Gbox. Oh, have I got my ES6 syntax wrong? Sorry. Yeah, it wouldn't need any parentheses if you think about it. It's not a function. Maybe I'm thinking of it as a function, whereas the constructor is a function. Let's just see if that works. Okay, that worked. So we got our box object. It's a proper object, not just a square painted there, but a true object. An ES6 object in the middle of the screen. Wonderful. The blue is a little dark. I don't know. It might look okay with the golden spiral. So let's just see if I can prove something. I've never tried this test. What if we put our class at the bottom of the file? I've been told that this won't work because if we try to instantiate a new Gbox, at the moment the compiler has never seen a Gbox in its life. Now usually JavaScript will, I think it's called hoisting, the compiler will put into memory variables and functions that you've used anywhere in the file, the JavaScript file, so that if you call a function or change a variable somewhere in your code, as long as you declare that variable or define the function somewhere else, it'll still work fine. This is not the case for classes declared in this way, prototyped in this way. This Gbox will not be hoisted in memory before the fact of its initialization automatically. So this shouldn't work. So now, if this works, I've been lied to, and I've passed on that lie to you. It works perfectly. It works perfectly. What has gone on? Let's refresh. If anyone watches this, I would love for you to teach me why that worked, because what I've read is clearly wrong. It's clearly wrong. So I can put my class down here. It's fine, unless it's not using. I don't know how to use strict actually. I shouldn't be doing this. I should just be getting on with the tutorial. Let me just yeah. Let me not experiment. Let me not experiment. Well, there we go. I'll put him down there. He works. Okay. Right. So it knows what a Gbox is. So it must have put that into the compiler. Must have put that into memory somehow. Let me run that again. Close that down. Command save. Wow, it's definitely working. Okay. So ignore all of that technical nonsense that I thought was true. So it's not true. Right. So anyway, we've got our box. Now we want to be able to draw a curve going through it, or should we try to? Let's just try to make a new, a smaller box. So remember, we want to shift it to the right and up, and we want to decrease its diameter by the golden ratio. So we need an iterate function. Iterate. Okay. So what we're going to do is keep track of the iteration number. So we're going to increment that, this n. So we need an n down here. Start at 0. And then we want to decrease its width. So this width times, oh, here's the golden ratio, first time, times 618. There we go. I don't know how precise you'd have to be. And then we want to move it. So we're talking about its position. And first it's x. I wonder, there might be a really nice way of doing it through some vector maths, which I don't know. So again, if you're watching and you know how to do that, and it's much more elegant than this, please let me know. So this position equals, plus equals, I guess we can do, equals itself plus this amount. So we want to go, I don't know if bringing up a picture will help, or shall I just code it? Okay, I'll just code it. We just want to go, so we're at the center of the square, we want to move across half the diameter so far, plus a little more. So we want to go this dot width divided by 2. That makes sense. Oh, that didn't make sense. Plus the new width, half the new width. In fact, there I need to be talking about the current width. So let's not do that yet. Okay, plus, so we want to do that again, but for the new width. So we want to say essentially the same here. So we're timesing the width by the golden ratio. And that's just in case our bod mass doesn't work there. There we go. There we go. So we've shifted it along half the diameter and then half the new golden ratioed diameter. Okay, so we also need to move our little square up. It needs to go up. We've gone to the right and we need to go up. Right. So we now want to say this pos y minus equals, because we're going up. That's minus in 2D, a 2D coordinate system. So how far do we want to go up? We want to go, I think it's just half the new width. I think it's half the new width. Let's have a look. I think I need to picture it now. I could cheat here. I won't cheat. So this width times 618, that divided by 2. Is that correct? That looks too... Oh, it's just exciting to find out. Anyway, so iterate. What have we done so far? We've incremented our iteration number. We've shifted right. We've shifted up by a mysterious amount. And we've made sure that our width is now scaled down. I think that's... Oh, no, I think that's all we need to do. So let's just see. I'll just run it without iterating. So I haven't called that function. So we still get our white box. So what we want is another smaller box to appear there. Let's just think about this. So we've increased our x by half the current width plus half the new width. And we've moved x. Yes, I think it wants to go, that's right, half. I should never say that. Yes, that's right. I have no idea if that's right. It looks like half the new width. Anyway, let's iterate. So all we're doing so far is rendering Fibly in the setup function. We don't need a draw loop, we're not using any animation here, but what we're going to do is check for when the mouse is pressed. I think mouse pressed also triggers an event that will be called if you tap the screen, if you're using a touch screen, which I haven't tested, so it's probably false. So mouse pressed, we want to say, Fibly, can you go and, not render, can you go and iterate and then render? That would be delicious. Okay. Let's see what happens. We can iterate as many times as we like if there's no basic bug. Right. Fibly, you're exactly the same size, and what have I done here? What have I done? Let's go and have a look at iterate. N++. This position, move right, plus, I think I have to, divide that by, no, why? Oh, times equals, sorry. You can't just times it by the golden ratio. Times what it already is. So this means this width, or should mean this width equals this width times. That's a mistake I've never made before. Times equals, there we go. So that's the main problem. But I think I should be dividing that by 2. And then, what am I doing? Timesing it by the golden ratio. 0.618. By the way, this little calculation should work in the following order. It should do division before it does the multiplication. Not because this comes first, but because of the BODMAS rule, which is like an acronym for talking about, it'll do brackets first, talking of which, I haven't put a bracket there, the ordinals, division, multiplication. I'm not going to do the rest of it. Right, there we go. So at the very least, we've still got our initial square. Aha! So this is looking pretty good. The ratio is now being corrected. So kind of as expected, I haven't moved it up the right amount. Let's just have a look. I need to move it up. What do I need to do? I need to move it halfway across this distance. Does that make sense? Halfway up that distance, yeah. So I don't need to do that. I just need to say y minus equals half the current width. That should be correct. No, of course that's wrong. It's quarter the current width. I've just moved it to the top of where it is. What's really disturbing, is that this is taking me longer to work out the second time than it did the first. So I don't know what's going on in my head. Memory is slower than reasoning in my head. Here we go. So it's still wrong. What am I doing wrong here? There is something amiss. Divide by 4. I did do it divide by 4. This width divided by 4. That is right. That's got to be right. Let's just have a look. You know what's disturbing? I don't remember having this issue when I first worked it out. Right. iterated. So the x is completely fine. And let's just think. Yeah, wherever it's going to be, it doesn't matter about its ratio. It's simply got to be halfway. Simply halfway. Or does it have to be? Okay. Let's. Oh my god, I'm just hacking now. 618. All the elegance of Fibonacci and math has gone out of the window, and I'm just guessing. So now it's less. Oh right, yep, that bug. So what I'm guessing is I do need to move the object up the y-axis at the new scaled down ratio, scaled down size. Right, that's still not working. What am I doing? I'm gonna have to abandon the video. I've been caught by a simple bug. I'm just checking now that all my numbers are correct. 618, 618. Yeah, the x is fine. It's the y. No, why did I put a 2 there? It will do that divided by 2. I'm sure I just tried that, sorry. Right, I won't abandon the video. I will instead cheat. Let's see what I did last time. So here's the equivalent. This position x plus equals this width divided by 2 plus the new width times. I'll do that in a slightly different order. So y, this width. Oh yes. So it's going half the diameter, and then slightly less than that is the half the diameter of the new length of the new width. So it's this number. I'm really paranoid about my bracketing. Minus the new width times 0.618. Okay. Not this one. Not you. Right. Possibly too many brackets in there. Let's just see what we've got. Oh my god. What am I doing? This minus equals width divided by 2. Oh, that divided by 2 times the golden ratio. There we go. Right. kind of success. Right. So God knows what would have happened if I tried to do that again. When x is still going to the right, the x position for this new square. Oh, let's just do that now. So what's happening now is that the new square is always spawning to the right and up, infinitely down there towards eternity. What we want to do is say, actually, our direction now has changed to go down. Then we want the next one to say our direction is going left, then up, and then right. So we're going to have 4 directions. That's going to kind of repeat. So what I'm going to do, I'm going to save time, because you've indulged my ridiculous bug long enough. So I'm going to copy my previously worked out code. There we go. Once again, this is the bit that could be far more elegant, I'm sure, using some vector maths or something. Or maybe using the rotation, as you'll see later on. So I'm doing exactly the same thing, but taking into account the fact that once we've moved to the right, we're now moving down, then we're going to move left, and then up, and then repeat. So we've got 4 directions. So we need a new member variable, direction. So this door equals 1. So 1 means we want to go right first. And then each time we iterate, it also increments the direction. And here we just check if the direction is 5 or more. I don't know how it could get more than 5. This direction resets to 1. And then we've simply got like a tree of a cascade of if statements about the direction. So if we're in direction 1, do what I just half remembered, mixed up and muddled. So move the x to the right, y goes up. If it's direction 2, x goes to the right, with a slight difference here. It's going to move in a different amount, a less amount, so the equivalent of the amount that we moved y last time. Direction 3, so it looks like x now is moving left, and y is going down. And then finally, direction 4 should going up, so x goes left and y goes up, and then we're back to direction 1. So that's how that's working. And then we make sure that what we've got a G-box is the G-box scale diameter is width is scaled down by the golden ratio. So we've implemented this new code. Why is it? And I've clearly started direction on the wrong number, but hey, it's working. So I want to start direction in the constructor function on 0, meaning the first time we iterate, it will be 1, so it'll be moving to the right, and y will be going up. There we go. That's what we want. Lovely. Now, in my original code, I did some other fancier things. I looked at whatever scale of window you get. So if you're on CodePen, or maybe like me, you've got like a tiny window here, but what if you've got full screen? That's going to affect how good it looks in terms of the size of this whole object or series of objects together. So what I did was I determined that initial width by looking at the size of the screen. So we'll do a mini version of that. So we can say, Fibly, your width, so that's the third argument, the third parameter we pass in, is going to be the height of the window. Oh, these keywords, by the way, refer to the window width, window height. Sorry, not the window's height. The canvas's x and y are stored in width and height for your convenience. So I'm going to say the height divided by the golden ratio. That would be nice. Why not? Let's use that. Let's just see if that should look bigger than 100 as we had it before. Okay, that's huge. And as you see, that's kind of too big for this window, so it goes out. So you can be a bit cleverer than that, and you can fiddle around like I did before to kind of check that it's always on the screen and to take account of the new. Made that worse. Oh, of course, the width is longer. Let's just say height divided by 2 times 0.618. There we go. So it's fairly big, and it's close to being in the center of the screen. So that will do us just fine. I'm also going to change the render now. I'd like our square to have a bit of alpha. So in its render function, before we draw him, we're going to say fill. We still want it to be white. It looks quite nice with the blue. And then add some alpha. And maybe let's try and refer to the ratio, 61. The ratio is meaningless outside of being a ratio, but Let's try that. 61. So we should have like semi-transparent boxes. There we go. That looks okay. Right. So really, we've got one more thing to do. We've just got to draw our curve. Let's try to hurry this up. So this is going to take place in the render function, and we've got to rotate. And we're going to do that. When are we going to do that? Can I succeed without looking at my cheat sheet again, about my previous version? I think we have to rotate it. Yes, sorry, after the translate. We still... Yes, we want the new box to be the center of our origins. When we rotate, nothing's like orbiting doing that. We want to... Yeah. So if you want to if you want to rotate your own head, make sure your head's coordinate system is in the center. It's your object's center is centered on the origin of your coordinate system. So we're going to rotate here by, now the rotate function, which is a P5 function, must have its parameters in radians. That's not true. It will treat any number you put in there as though it were radians. So if you put 90 in there, standing for 90 degrees, that won't mean 90 degrees in terms of the rotation that you have, which might produce a bug. So I want it to be 90 degrees, so I made sure that I've called this function radians to convert 90 into radians. And then I want to times that by n. Now what was this n? This n was the number of iterations, whereas iterate, and we increment it each time to keep track of the iterations that we've passed through. So the first rotation will be n equals 1. So that'll be 90. Sorry, I went off screen. And then it's gone 180. The next number, 270. And then back to 0. And it doesn't matter that we're going to go over 90 degrees. It will just represent turning an exact corner. So that's what we're doing. So that's why n is handy. My explanations are horrible. I'm so sorry. But hopefully this will be clear in terms of the code. So we're doing that. So when we draw a curve, this curve now will be rotated according to our box. So that's where we've drawn the rectangle. So now down here, let's draw the curve over the top. So we want to draw the curve after we've drawn the rectangle, so that it will appear over the top. And we're going to use a P5 function called begin shape. And we want to make that shape not out of lines or triangles, but we want to make it out of points. So we use the capital points. And then somewhere down here, we're going to end our shape. And how do you get those points? So all you have to do is create a vertex or vertices, lots of little points in between these two function calls, begin shape and end shape. And P5 will go and work out how to connect them together or draw them. So what I'm going to do is use polar coordinates to kind of go around a quarter circle to make our curve. This was the bit that I had to kind of like think through when I was kind of experiment with when I was doing it the first time. So let's give it a go. I'll give it one go, and then if it doesn't go right, I'll cheat again. I don't want to cheat again. So we need a loop. We're going to just create one vertex, but putting it in a loop, it will create lots and lots of vertices. So each vertex will need an x and a y. So we'll call that Vx and Vy. There we go. So we've just got to work out what Vx and Vy r, so let vx equals something, let vy equals something, and let's iterate through how many we want. So we want let I equal, so we want to go from 90 to, I'm going to set, I remembered it was 90 to, sorry, someone just walked in, to 180, I think I put. Hello, just recording a video here to make a golden spiral. It's not going well. 180. So we're going to say while I is less than 180, and increment I. Okay. So we're going to use polar coordinates here. So this is a number of points, number of vertices that we're going to create. That's 180. So the origin, if you remember, is going to be the bottom right-hand corner of our square. So that is this dot pos dot x plus this dot width divided by 2. There we go. So we've got our origin. Let's put that all in brackets. There we go. Plus so this is a radius, and that's going to be, thinking about that curve, it's going to be exactly the same length as the width. There we go. I'll try and explain why, if you're visualizing it. So if you imagine where it starts, the bottom left-hand corner, apologize if that's the right-hand corner, the way you're looking at it, bottom left-hand corner, the y component of where that point is compared to the origin is 0. If I move it up, y is going like 1 away, 2 away, 3 away, 4 away, 5 away from the origin's y. And the x is really far away. It's the maximum it can be, because as soon as that curve changes, it does this, like you're steering a wheel. So, so the maximum distance it can be away is exactly the length of the width. So this width times, and now we use our math, so it's cosine, if you're determining the x position, that's going to be I. So we're looping around and we're basically changing that angle, 90 to 180. That doesn't feel right because we're doing a quarter of a circle. Oh yeah, sorry, of course, yeah, 0. Of course it's right. 0 to 180 would be would be 180 degrees. My goodness. There you go. That should be it. Oh, I'm going to use math cosine. Seems to work quicker. And then we're going to do something similar for the y component of that vector. So this position y equals, should that be plus equals? No, equals the origin of the y plus this width. That's just the radius. No, it's not. That's the corner of the square. Yep. So it's going to go down, which is plus y. Then we've got the radius times sine of I. Okay, so we should have drawn our curve now. So it's going to draw those points. Let's just have a look at it. How long? Oh, this has been over half an hour, I think. So we've got no curve happening. Let's just see if I've got a bug. Nope. What might I have done? let's just increase stroke weight. Stroke weight 7. Stroke yellow, by the way, is full, or lots of red, lots of blue, lots of green. That might now change the color of my squares. I can't remember. No, we've got, it's down here somewhere. It's down here. And it's gone up there. I think the issue is, we don't want to go from the position of the box because we've actually translated to the position already. We've shifted our the center, our origin of our drawing system. Let's just try that again. Okay, so there we go. The curve's kind of working. Looks like I'm moving through too many points here. 90 to 180. I don't know where my circle's starting. 90 to well, in my mind, I should do that. That makes sense to my mind. Still loads. We better change stroke and stroke weight for when we're drawing our rectangle. Sorry, we need to change the stroke weight back to 2. Would look good, and it wants to be coloured white. No, it doesn't. It's white would look good for the box side, the box sides. So what's happening? Let's just go 0 to 90. We shouldn't have a full circle. That's what's bamboozling me. Why on earth have I got a full circle? Oh, does this take radians? Uh, 0 to 90, so yeah, to my mind 270 to 360 is where I want to be. That's the last quarter of the circle. Okay. That's very pleasing. That's the kind of thing we want. So it's going from, so if that's, is that 270 to, let's go from, what do we have originally? 90 to 180. Does that flip it? Else we're going to have to experiment with a few more. 90 to 180, what else can we do? 0 to 90. No, I'm liking 180 to 90, you know? Let's go backwards. Let's go backwards. Does that work? Okay. Oh, right. We've got to decrement. This is, by the way, this you shouldn't code like this. This, you could be here for decades. Have we already tried 0 to 90? Yes. Let's try one more. What else? I can't remember what we've tried. 180 to 270. There we go. So if this one fails, then I'll go and cheat again. Oh, it's worked! My goodness. Oh, that is amazing. I only had to cheat once. Right. So I think we've done it. There is how to create Fibonacci's golden ratio spiral. Sorry, this doesn't necessarily show the Fibonacci sequence, although it's in there. Fibonacci's in there. So thank you very much. Apologies for the bad maths. Well done for sticking with me and believing that we could do this. By the way, this is version 1.618. Do improve on it. Goodbye.